used for DeFi, damn vulnerable DeFi. So we are stopped in the puppet, and today we're gonna crack that doing some drawings, right? So 1 second, let me post about this. I don't want to check the chat, should be all good. I don't know if it's still okay. I'm gonna post with the link, right? So where we were trying to understand the contracts, right? First person. We could use Copilot here to explain to us, explain the formulas for add liquidity, the mint token ratio, and so on. So we can use here, they're using Claude. That's funny. That's funny. Okay. Look in the function. So that the part we studied, right? So the formula here, maintain the current price ratio. The +1, it's rounding adjustment to favor the liquidity provider. Right. Must not exceed max token parameters. And liquidity mint formula. So the formula for the unit tokens are proportional to the Ethereum that you are depositing relative to existing Ethereum reserve. So that's something I said before. The total supply here is the total Ethereum there, and you're gonna receive 10 unit tokens too in the first adding. So in the second adding, so second time here, if we add 1 Ethereum and 1 DVT, you should be receiving 1 unit token. That's gonna be responsible to allow me burn that one. It take back these. If you deposit 10% of data reserves, you get the 10% of the existing unit tokens minus any issued to the. Oh, okay, they have a calculation here. That's not clear here. So I deposit 10%, right? So 10% is exactly the one I deposit. Divide by how much? The reserve. So should be 1. And now the total should be 11, right? So it should be 11 there. That's total supply, and I have almost 10%. Maybe that's why they increase 1 as rounding. So here, the first scenario, the total liquidity is 0. The key invariant. So both scenarios maintain the constant product formula at the core. Yeah, that should be constant. So ETH reserve plus token reserve. So in that case, here, the constant should be 10 plus 10. That's the formula for, I think, x key, right? If I'm not crazy, if I remember correctly. And now that should be constant. It means if I want to take 1, let me remember this. If I want to take, if I want to take 1 here, Ethereum, I'm gonna need to give DFTs, right? And the constant need to be constant. So remember, so 1000 divided by 9. Then, wait, oh, that's a 100. Too much zeros. So 100 divided by 9 should be 11 on the other side. And so I think the way to hack these is see how they are defining the prices, right? So let's go here. That's my Z. I think that light in my face, it's making me crazy. You see, get a little more darker, more comfortable for my eye. Here I was trying some Fibonacci's, and because I'm studying dynamic programming. That should be 2. That should be 3. Right. Yeah, so they have that formula for calculate token to Ethereum. So let me check something here. What difference for input price and output price functions? I don't want to get spoiled, but I want to get some information easily. I think here's for fees. We can do some calculation. We can do some tests here. Calculate what? Calculate. Yeah, so here token sold. To calculate token Twitter. Okay, so here I am selling DVTs, and I want to know how much it costs as Ethereum depending how much we has in reserve. So here's the initial reserve. That should be 10 and 10. 10 and 10. And we can get the price here, price so we can run forge, we can call Puppet, it's gonna fail, right? But I want to see the price logs. You can even get less VVVs if you want. Let's yeah. So let's go less VVVs. Here the price, and probably need to divide by these. Oh, that was less than 1. Okay, so I cannot divide. I think we can see here. No, that's the here. Yeah, we can see here 9 and 17. Those should be 0.9. So a little less than 1. I think because of the thing here, right? The fee. So let me confirm the calculation. So this should be equal. Ether should be 10. 1, 9, 9, 9, 10. I think I 1 0 more. So here we're gonna divide by, it's basically equal here, right? No, that's a sum up. Okay, that's these cancel out, right? I can cancel that. No, because of this sum. So tokens in reserve, they increase that to remove that, no? Right? To increase for these. So 10 increase by a lot. That should be 10,000 plus 9997. 1,9997. Okay, let me see here what they said. Short answer. They do opposite things. So input price. So for example, get token to Ethereum input price, get Ethereum to token price. Given one amount you are selling as input, return how much of the other asset you receive after Uniswap fee. Yeah, so that's the fee indeed. It's a strange way to take out fees, but maybe it makes sense, right? So fees is like this. We're gonna multiply. But maybe they have some shortcuts, mathematician shortcuts to do the calculations and take the fees. So if I multiply by 1, how much is less, right? Yeah. So less, yeah, 1 less this should be 0.9997. For each one, right? For each token, they multiply by this. Yeah, I think the 1000 increase here is to don't have zero problems. Okay, and the output, give the exact amount you want to receive. So input, you're gonna give token and you're gonna receive some Ethereum. I can give some Ethereum fix, like 1 Ethereum, you're gonna receive some token. Here it's otherwise. Here probably I tell how much I want to receive. Give the exact amount you want to receive. Tell how much the input asset you must provide to get that output. It roundups to ensure you provide enough because of integer division. So key formulas that's gonna be use the constant product with the 0.3 fee as input, and desired output require input input reserve, output divide, etc. And +1, the +1 accounts for rounding up, so the swap covers the desired output. Right. So not an effective factor. 999 divided by 1000, that this divided by this, I think, encodes only 99% input to go to the only 99.7 of the input goes into the pool for price calculation. Use input if you know how much you plan to sell, you want to know how much you go back. Output if you need exactly how much X the other token you want to compute how much sell. Output checks, so you can buy more than the reserve. Small integer means include to avoid underpaying the intermissions. Okay. Yeah. So the catch here is the pricing defined here. How they calculate the pricing. He's calculated the pricing based on the token balance. Let me remember who is token here. Token here is the token. A Uniswap pair is the exchange, right? Okay, so balance. So balance, it's the Ethereum reserve. E-token balance, it's the DVT token. So let's try see how that works. So note that the price is used here to calculate the amount. So let's say I have 10 here. They're gonna increase and divide by the token balance, that's also 10. So the price should be 1, right? So 10 divided by 10, right? You can see why they increase here. So if we remove, we're going to receive just 1, and we want to have the decimals, right? So that's the count. Now, what's necessary to we make the token valuable less? So if you go, if you take Ethereum, you see now that value 0.1, Another way to do that is we can increase Ethereum. No, that one don't works. Wait, that's 10, right? Yeah, so, or we can increase here, right? So if we take 1, that's gonna be 9, that's gonna be 11. It's already changed the price. It's more cheap now. So if we take 8 here and add 8 here, now the price is 4. We check if the constant it's keeping. It should be 100, right? Or around 100. So 100 divided by 8 should be 12. So let's do some tests. So what I want to do is make the DVT price drops. So I want to sell DVT, right? I want to take Ethereum, and I have some Ethereum DVT. As a player, I have 25. So let's try an initial token. I have 1,000. That's a lot. So what I want to do, I want to take out Ethereum. I don't remember what's the function to call. Let me check. I don't remove it and add liquidity. I want to do some swaps. I guess they have swaps here. Here. Convert tokens to Ethereum. So let's see. Here. I think the minimum Ethereum I want to receive. No, minimum Ethereum I want to give, because inputs is how much you're gonna give. The Okay, looks like back. I don't know what's so heavy. I don't think it's a terminal. But I could close, right? Maybe helps a little bit. I have some Brave, a lot of tabs open too. I'm gonna close all. And let's see. Okay, so here, add to sold. minimal tokens to receive. I think minimal tokens can be 1. Right? And deadline should be greater than the timestamp. So timestamp plus 1 also should be enough. Okay, let's call this function. They have the interface here. We can check, for example, if that functions exists. You can see these. I think these Ethereum to token swap inputs, minimum tokens swap as Ethereum, and the deadline. No, that's not the. That's not. That should be 1. We have transfer to. Okay, they do a different recipient. So let's go this. I don't know how they call exchange. Uniswap. Yes. Like I said, so timestamp plus 1. That should be 1. I don't think they have these. And should we have some returns, I think. So return number. Can I set option value on a known and payable function type? Oh, that's not payable? Oh, that's truly not a payable function. Wait. Wait a second. That's a payable function. It's crazy. So I think they missed the implementation here. It should be payable. Now let's go D. And let's run. So what's gonna happen? It's we're gonna should be taking 1 token based on the price. They return. That's the amount. That's the new price. That's the tokens we got. Okay. So let's go 1 here. One should be returning, take some fees. Yes. So here they take some fees. We got return as we expected, the formula says. So now the ratio inside the pool changes, right? if I try calculate again the price, I could do something like that, right? That should be returning, because because I give more Ethereum, that should be returning more token, I think. Okay, they expect the same. I think it makes sense. So let's take otherwise now. I want token to Ethereum swap. And probably we need to put as payable. Or maybe we need to use output. Get token to Ethereum input price. Man, it's so confusing. Get Ethereum, why they call token sold? Why these names are so confusing to know how that gonna be used. Also missing payable in some. Okay, so we use that one. We send Ethereums and took tokens. The minimum token expected, so that makes sense. But then here's tokens bought. Don't make any sense. It's how much I want to. I don't know. You are right to be annoyed. Names are terrors, and the interface in the repo has some inconsistencies and missing mutability payable notation. The method intended harder to read. Below, I explain the naming schemas. Okay, so naming is Ethereum to token. You supply Ethereum, message value, and receive tokens. Okay, so far so good. That's why I was looking for this one. So that should be payable too. That should be payable. That should be payable. That should be payable. I should be copying, pasting. I forgot I cannot do that. Yes. Okay. Then token to Ethereum, you supply tokens and receive Ethereum. Okay, but I cannot find this. Oh, no, I can't. Yeah, so that's the I want to use token sold, minimum Ethereum deadline. So like gonna missing one variable. Token to token swaps via intermediary Ethereum, and token to exchange swap tokens to tokens on another exchange. Swap style. We have swap input, swap output. You specify the input amount you send. The function returns the output amount you receive. Swap output. You specify the exact output amount you want to receive. The function calculates how much input you must send. So caller must provide at least that much. All right, and then you give money back, right? That's a little less common, right? But makes sense. Okay, token to Ethereum swap input, token to Ethereum swap input, token sold. So I'm gonna give 10, I guess. Yeah, that should be 1. Yeah, that should be 1. So here I need a proof, probably. We need swap exchange. Wait, I need the amount, right? The amount I want to go gonna be amounts token. Let's go 10. Have 1000. Amounts token. Okay, so these calculations don't make any sense anymore for now. And let's see what's gonna happen. So I send in 10 and take out 10 probably. Yeah, approve it's missing something. This should be address. And approve token, approve amount. Yeah, I think that's should be right. If that's not right, we can find out inside the token. Spend that amount. Yeah, that's correct. I think what's just missing is the return. That I don't really care right now. Wait a second. Yeah, that should be working now. Oh, 2p, right? Yes, it's 2p's. All right, so here we took some Ethereum back, right? How much it is? We can see here the player receiving Ethereum as a fallback, but they don't have the formattation. Here they have. So you can see we took for 5 Ethereum, right? So we can check the price right now. So maybe we can go back with the prices here. Maybe one less. Oh, the price is the same because I forgot to change the reserves. So we should be maybe stopping use that function and use man, why my machine is so slow? I need to really type everything. That should be get token to return input price. Yeah, I want to know both of these. So if I how many tokens to bought, how many I think that one's more where we want. Copied, paste. Why it's not pasting? Now it's pasting what all. Damn. Okay. And now I want always one. It's missing E. And the first one, yeah, also like this. Yes. Okay. Let's see. Yeah, so here, the price is get Ethereum. But it's get Ethereum, but it's output. So how much tokens? Man, that's so confused. That's so confused. Get Ethereum to token output price. You're gonna return Ethereum price here? How much Ethereum? Maybe it's that one. Right. Oh, okay, that's this obviously that's the same because the ratio should be the same. Why they change the 1.1? Why they worth so much? But you can see the price drops, right? You can see that price drops by a lot. That's gonna allow us to get a lot from these. Here they explain some semantics. So any Ethereum 2 functions that consumes Ethereum must be payable. Okay. Input returns the amount you get for a non-input. Output returns the input. Output returns the input required for a non-desired output. So for the that's why it's round up. Okay, so I think we don't want. We want inputs. Input gonna be more precise. So I'm inputting always tokens. To know the price in Ethereum. Okay, yes. Yes, now makes sense. So that was 0.9, now 0.2. So if we take 1000, oh, they're gonna give an error, right? Because they don't have 1000 there. We took all the Ethereum. Look the price. Look at this price drops. for a lot. Here we probably have 9 Ethereums. And here I'm probably gonna need to go like this to see the logs. So the amount transfer here is 31 something from to deployer. What the fuck is this? I think that's the beginning, right? I want the later. That's minting. That's the unit tokens, I think. Proportional unit tokens. That's remember me a cool research called Uniswap book. I think they have V1 somewhere, or maybe they don't. Oh, yeah, but the V3 still have some formulas. Yeah, here I think that's the V1. Yeah, we should be reading that. So different versions. Tell about the V1s. So V3 was launch, or launch. One it's food. Here's the constant product function, like I draw here. So where X is the ether reserve, my face is what? Yes, here. Where the X is the ether reserve and the epsilon is the token reserve, and K it's a constant. Uniswap requires that key remains the same no matter how much of reserve there are. When you trade ether for tokens, you deposit your ethers into the contract and get some amount of tokens in return. Uniswap ensures that after each trade, K remains the same. This is not really true. We will see later why. Here, the problem what the heck gonna happen. These formulas, it's also responsible for pricing calculations, and we will see how. So smart contract development. So blah blah blah, blah blah blah. Project hard hat. We don't care. We know everything. This. So the exchange contract. The V1 has only 2 contracts: the factory, the exchange, and the V2 they call LP or something, right? Pairs. So exchange it's a kind of token. Yeah, the token address is a state variable which makes it accessible for any other contract function, make public users, providing liquidity. So we already learned liquidity makes trades possible. We need a way to add liquidity to exchange a contract. So here, the token that make the pair amounts and transfer from sender that did approvement to this. By default, contracts cannot receive ethers, which can be fixed via payable modifier that enables ethers receiving in a function, and ethers sent along with the function or added to the contract balance. Depositing tokens in different thing. This token balance or store, etc., etc., etc. So the implementation is not complete. I intentionally made so focusing pricing functions. The gap now it's a get reserves. So here they taking only the reserve for the token, and we can now test add liquidity. That's something also cool, that when you check for balances, we can modify, break the value, just sending tokens to the contract. And we can now test add liquidity to ensure everything is correct. Okay, nice. They did some tests. The test they did was approve add liquidity as this with some value, and they check the balance. Price function. So let's think about how to calculate the exchange price. My tempting to think the price is simple relationship of reserve as x p price for x, it's this divided by this, or price for this is this divided by this. And this makes sense. Exchange contracts don't interact with centralized exchange or any other external price oracle, so they cannot know the right price. In fact, exchange contract is a price oracle. Everything they know is Ether and token reserve, and is only information we have to calculate prices. Let's take this the idea and build a pricing function. So check it, they have, and then divide. And then let's test this. They're gonna test, and they check Ethereum per token. So let's see here. They approve 2000 way in tokens, and added liquidity these 2000 tokens with 1000 Ethereum. So we have more tokens than Ethereum. That should be 2 times, right? So each token, wait, we have more Ethereum, right? No, we have more tokens. That should be, man, why I'm so slow to do the calculation? It should be half, right? Yeah, half. So here, Ethereum per token. So you want to know Ethereum, so you put Ethereum divided by the token. So they're gonna give that, and if you give the reserves reversed, you're gonna take as 2. Right. We deposit 2000 tokens, etc. The price of tokens in Ether should be half, and the price in Ether to tokens should be 2. Whatever, the test fails. It say you're getting 0 Ethers in exchange for our tokens. Why is that? So here they're gonna get 0. The reason that Solid support integer only floor rounding. The price 0.5 gets rounded to 0. Let's fix that by increase the precision, right? They're gonna increase the precision. After repeating the test, that we're gonna pass. Now that represent 0.5, that represents 2. Okay. Everything looks correct, but what will happen if we swap 2000 tokens for Ether? We will get mu Ethers, and this is everything we have on the contract. The exchange will be drained. So let's see here. They have 1000 only, right? And if I want to take out this, I just need to provide 2000 tokens, right? I think they said that. Yeah. If you give 2, because that's the price, that's gonna be dry. Apparently nothing is wrong with the pricing function. It's allowed to drain an exchange, and that's not something we want to happen. The reason of that is that the pricing function belongs to a constant sum formula, which define key as a constant sum of x and y. The function of this constant sum formula is straight line. Okay, wait, it's a little confusing. The reason of that is that the price, wait. And they're explaining why, but that's kind of obvious, right? Marcos, olá, boa noite. Buenas noches. Marcos. É Marcosi, ou 0Z, né? Estamos aqui estudando, lembrando as fórmulas do Uniswap V1, porque eu deletei o Escolhe Draw? Jesus amado. Nossa senhora. Como é que eu fiz essa proeza? Esse browser aqui eu não me acostumei com os atalhos dele ainda. Dá pra ver o gráfico aqui, né? Aqui tem X, Y e... Aqui ele tá falando 3, né? No nosso caso, 3 e 6. Mas ele tá mostrando a linha. The function of this constant sum formula is a straight line. It crosses x and z axis, which means it allows 0 in any of them. We definitely don't want that. Okay. Correct pricing function. Let's recall the constant product market maker, which means the formula. Does the formula produce a better pricing function? Let's see. The formula states that key remains constant no matter what reserves, or every trade increase a reserve of either Ether, or every trade increase a reserve of either Ether or token and decrease a reserve in either token either. Let's put that logic in formula. So that's something I didn't know before, like the function born, because they don't want the key be 0. And that makes sense, right? Because you just need to give less tokens for people, and that's gonna create a price variation. So let's put the logic in formula. So the logic in formula is x plus the different, that's the delta, right? The delta x multiplied by x less delta y equal x y, where delta x is the amount of the ethers or tokens we are trading for. This amount of tokens of ether we are getting exchange. Having this formula, we can now find these. Now they are, we should be trying to understand that formulas, right? That's the reserve. That's the amount I want to take. So let's say they have 2000 tokens. I'm gonna add more tokens. That's Ethereum. I'm gonna remove Ethereum, and that should be up equal to product K. And because that's it's constant, I'm gonna receive less here if necessary to keep the reserve in the same values. Here they pass where x is amount afters or tokens we are trading for. Yeah, like I said, right? They are putting these, they change the formula, right? I don't know if they did the calculation here, like x by that. Probably right, because we have this on the top. And they took out this for that side. Then we have how much you're gonna receive. It's based on the reserve plus the amount we send divided by the new total reserve. So the naive formula just do this x for epsilon every time. But these, they take in consideration the amount that get in, and they, wait, when you multiply epsilon by x delta, if that's 1, we already has there. Yeah, that looks interesting. The function now respect input amount. Let's try to program it, but note that now dealing with the amounts, not prices. So get amount, some input reserve, some output reserves. Yeah, so that formula is the final formula. So input amount, this, the x, multiplied by output reserve, this, divided by input reserve, this, plus input amount. I want to see that in a graph, in the chart. We have a program to this Desmos chart. Graphing calculator. I don't remember how to type formulas here. Can I copy this? That don't look right, right? Maybe I need to copy this first. X, the data is slider. Oh, that's now nice. Yeah, but I need to define stuff, right? And Auba, Paul Otter said Auba. No, it's not a slide for this. It's a slide for X. Okay, we can use another letter because I don't think he understands. Yeah. Let's go C in D. Yes. Now we can see the line. Beautiful line. So if you go 1000 something and 2000 something else, of course that's gonna be so big to show. They have a button to. Okay, that's negative. Why that's negative? Eu sabia que Desmo tinha dark mode. I don't think they have. Because I'm using this. Maybe they have dark mode, I don't know. But because I'm using the dark reader. Yeah, maybe they don't have. Let's see. Prepare your eyes. Oh my goodness. Okay, so yeah, so that's the correct formula. What I want to see is the other formula. That formula is, my goodness, D, right? We can call D can call like that. dx delta, right? Huh? Really? They think it's 2 letters? Tentando fazer o quê? Tentando see that formula in graph. Just because it's more easy to grasp. But I don't know, I cannot use something here. Deus não aceita duas letras de uma variável. Tem que usar underline pra... Oh, underline. Like LaTeX, right? I forgot everything about LaTeX. Okay, nice. Thank you. We have a mathematician here to save us. Mm-hmm. 1,000, 2,000. And now the other formula. So these should be the, oh, that should be this, right? I can disable, right? I can disable the formula. I don't remember how I can disable. Yeah, I don't remember enough to do this so fast enough. Não sou matemática, apenas um humilde cracudo de engines. Cracudo é ótimo. Que tipo de engines? Cracudo. Okay, so delta x. Yeah, they just changed the formula around. Now yes. Epsilon d x. I don't remember how to do division. Oh, nice. Se a ideia é formular uma equação, seria melhor usar o formato fx. Não é formular, eu acho. O que eu quero fazer é entender a proporção e a diferença das duas fórmulas, eu acho. Engine gráficas de software rendering, ou seja, tipo que não existe desde os anos 80. Engine gráficas de software rendering. Como assim não existe desde os anos 80? Tipo, Unreal Engine? Nenhuma? Ou você fala que não foi criada nenhuma nova desde então? Ou você fala as que são criadas para Graphic User Interface e não games? Explique-se. E aqui, se quiser, claro. X mais delta x. Aqui você falou para colocar a função, function x. Let's see. Oh wait, I'm missing something here. Really, I need to go like this. Software rendering use CPU for plot pixels. GPU. Desde que a GPU se popularizou, ninguém mais vende jogos com essa técnica. I see. So direct checks or direct X. Should I write my comments in English? I think it's good, right? For other people that can come around. You also engage with the conversation. That English is more universal. So direct X and what's they call the name of the other? That's for GPU, right? Or GPU or CPU. I don't know why they translate it. Initial release 95. CD rendering. Yeah, GPUs here. Maybe that's CPU. Injector on 2D. Shader, yeah, so I remember the shaders. That's GPU, right? DirectX, OpenGL, Vulkan, such or GPU. What I do is software rendering, where all you can see was made by logic, not specific radar. I see. I guess. Like you have some canvas and just use the CPU to draw stuff, right? Oh, that's why you use Desmos, right? Now everything makes sense. Okay, let me go back to this because I need to hack some contracts. But what you are doing, creating, or you work in some company, something like that? I have pixels. The canvas is optional. I could print out the pixels in a console. True. Or use assistant window call. Yeah, true. Like I said, canvas more like X and Y axis. But yeah, you're right. Canvas is something else. Okay, so the function here, every trade increase a reserve, right? And decrease a reserve leader, yes. So that's why they create the formula. He said that every time I put X, I don't understand why they have this as key. But every time they put X, oh, I see. Now I see. I remember now how to do that in mathematician. Sorry if I sounded pedantic. No, never pedantic. No. I just try hold myself to not sidetrack because normally in my lives I sidetrack a lot. But I love the subject because I already programming low level to like Visual Basic to do some animations, and probably did something like that. Also, use DirectX with Delph and what it was. I don't remember the framework name and the other stuff. And Vulkan, I did a little bit iOS development, also gaming, and also with the Unity 3D, and also some JS, JavaScript animation. So I play a lot with all the stuff in the past, so I like the subject. It's very cool. So, okay, so what I'm trying to understand in that formula is how they construct, to try understand the mindset to construct new formulas. So how they get these. So that was I'm trying to understand. Because formulas is just describing something you can reason about, right? So what they figure out here is every time the trade happens, so to give some more context, my Scully draw. I killed my Scully draw. So every time we have a, I don't know if you know the concept of DeFi and Web3 and tokens, blockchain, but here we have a pool. It's a contract that have two tokens. Let's say that, let's call that two tokens. Ethereum is not a token, but yeah, can call that token too. And we create a pool. Inside that pool, we put 10 Ethereum and 10 DVTs. So the pool exists to allow us to create an exchange where people can come here and buy DVTs, give in Ethereum in exchange, and so on. So they need to create a formula to make that works. I know blockchain as much as Pig knows about quantum physics. Yeah, they said the pig they said the pig has I think 9 years child brain. Yeah, maybe the child with 9 years and then in the next century probably gonna know what quantum physics is. So yeah, blockchain is a complex matter, and here we are in securities about blockchain, so it's a little more complex then, but it's also fun. Pigs play dump to avoid taxes. Yeah, for sure. Yeah, I was studying about pigs today to do some farm, and it's often they play dumb. It's too easy, right? Let the human pay the taxes. Yeah, so we have a pool with 2 tokens. That's not a line. And they need to figure out a way to give prices for stuff. So we here reading the post where they describe the first version for Uniswap. Uniswap was the first exchange, the decentralized exchange in the blockchain that's create that primitives we're seeing now. So they basically started creating like that, and so I could like just go directly for the answer I want, but I want to build the mindset to build new stuff. Because I already studied Uniswap v2 a lot of times, and v3 we have books here, for example, where we can study all the calculations behind. Now we have v4. The current is v4 now, and here they're gonna explain, for example, cross-tick. It's very cool concept to define prices in a different ways. I know how to use acrostics. I know that they have some um, how to spell that. I even don't know in Portuguese. It's not differential. Derivative. Yeah, I don't remember. The mathematician way to calculate the area inside the curve. Price as money or generic cost as money. It's money because we can use as money, right? But is the difference, right, in the exchange. So let's say I give you a pig and I ask you for in exchange something else. So we call that's money, right? But here, yeah, we want to define price as value as price because we are creating an exchange to people get in and swap tokens, swap stuffs. Okay, let's go here. And so what I'm understanding here in that formula is, hey, olive map. Aliás, okay, that's right. The comments looks reversed, right? I just saw now the comments in the top. It's like reversed. Come from the top. Good night. We are studying Uniswap V1 formulas. The mathematician get in the room. Okay, you're gonna help us. FM Ignite. Yeah, you're gonna help us now understand something here. Do you remember about the formulas for the Uniswap? Did you study that? Let me close some stuff here that we are not using anymore. So what we're trying to understand here is how they get to that calculation. And I think how they get this was like this. X plus this, it's equal this. Like I have a pool. When I add something to this pool, I'm gonna remove something for these pools, right? Then now they do the thing with the mathematician. I don't remember the name. They multiply this by this, this by this, this by this, this by this, right? I think they did that. We can use off-ground. I think that's the name. Ofran. They can do the calculation, right? Just come to here to say hello. I'm going back to my study. Thank you. What are you studying? Studying what? They don't understand the query. Because they don't have the delta. Okay, let me copy this. Oh boy. Now let's see if they understand. Have a good live night. Thank you. For you too. Okay, so that's, you need calculus. Yes, I need calculus. But not for now, right? Calculus are gonna need for the UniV3, I think. You're studying auditing as well? What are you studying exactly? Some pattern? It's kind of hard to see, right? Oh, they have dark mode. Okay, so we can disable this. Nice. I'm doing the updraft course. Ah, that's cool. For updraft course for Cifring, right? That's a cool course. They have Solidity Basics and also the audit. Where it is, this. What the hell? Oh, they have formal verification now. Oh. Ah, you learn it for the pipeline. Ah, so that's in the beginning of the course, I think. Ah, they have formal verification. Oh. Nice one. I like it. Yeah, I'm gonna need to study that later too. I'm probably gonna do some lives. Okay, so geometric figure, pair of its intersection lines, expanded from really equals 0. Assemble as in x86, more easy, I think. I can show a little bit. I think here we have all the contracts is like opcodes. So we have like push, log, push, push. So you have like a stack in a memory. I have a stack, a memory, because Ethereum EVM is a Ethereum virtual machine. So blockchain can run contracts inside a VM that have custom opcodes to do the manipulation like the registers in assembly. And so also you can write code as a U stack-based VM. Yeah, it's beautiful. Here I can now see some. Let me open another playground. Works wonderful. Man-made errors. It works well for the purpose of blockchain. And here's the assembly for this. It's very easy. Much more simple. You have a language called Huff. That's more tough to type, but to give more control. So for example, here you can call like the opcodes. M star, revert, pop, continue, the jumps. So I have jumps too, etc., etc. So the Huff, I think it's more close to assembly. I have my own bytecode language. I can give myself brain damage. Alternate from the why is delta it's squared? Yeah, the derivative is the name I was trying to remember. Yeah, okay, derivatives I know, it's complex matter. I try learn 3 times. The 3 times I learn I understand, then I just forgot. But here, okay, I just want to understand here's this. Okay, this is more clear, right? But why is giving delta? Don't make any sense, right? Why are you giving delta as different value? Okay, let's go Claude. The latex from. Because the LSD demos told the blockchain people to put on this card. Yeah, don't make any sense for me. And also for Alfran. Alfran also do not understand why it's happening here. They simply don't know what's happening. Okay, yeah, that's what I was looking for. That I was looking for. That this multiplied by this is this. This multiplied by this is this. Wait. No. This. Yeah, this is here. And then this. I don't remember. Oh yeah, it's the true name of, I don't know how to spell that. Chulu. Series of expansion and x0. Okay, well, that's for too far. Okay, that was too far. It's outside my pay grade, right? That's too much. Why they have 120 here? It is 6. No. That's irrational. Yeah, okay, I'm gonna pretend that I remember how they get to these. I think if I take this and put it here and ask how that formula came from the first one to second. Drugs-induced equation. Yeah, kinda. Yeah, mathematicians are kinda crazy, right? Yeah, so the expanded is expanded. Cancel out. Okay. Okay, so one step back. Let's do the expanding step by step. Just to make sure I remember how to do this. Yes. Distributive FOIL. Yeah, this multiplied by this. Exactly. This multiplied by this. Exactly. This multiplied by this. So I was correct. And this multiplied by this. All together. That cancel out if you want to put 0. And then we're gonna take one this, like this. Okay. Continuing. Right. Yes. Remove the 2. Then we have this, 0. Then take what I want to use isolate. Like they want to isolate this. It's already positive. So they're gonna take that to other side and take that other side. They take that first. I don't know why. I'm gonna sum up for these. Don't make any difference. Right. And now you put that in evidence because you have the 2 multiplied here. Both it's multiplied by this. So it's the same as the inverse of the distribution. So it's like this, because we're gonna this multiplied by this multiplied by this. Now, because you put that in evidence, you can divide both sides by this, but remove this. So you divide, wait, no, they divide by this. Why? Huh? Oh, no. They give this to that. Oh, instead of passing that to this side, left side, they just divide both sides. So that get a division and that get that removed. Now that's isolated. Ta-da! I would not lean too much on AI formats. Oh, they are good to this, to be honest. They are good to this. When you ask to explain that basic, because that's basic mathematician, right? Very basic. I don't think they can do very well. No, I think when they use in Python for calculation, now when they start using Python, that's the way they start getting more complicated. Yeah, that's easy one. Okay, so let's go back to our reading. So these become this easily, right? And because this formula exists, now we can create the correct formula. So this is low-level function. So this let's be private, and let's make 2 high-level wrapper to simplify calculations. So they created 2 functions to be easy to be used, called get token amount and get it amount. So if you're gonna take get token amount, you need to send Ethereum and say how much. They're gonna call the formula, they check the balance for the reserves and the token reserves as well. Here the same, the token reserve. Here is the function name should be token reserve, and here's Ethereum reserve, but okay. And they're gonna test. So they did a test. So now we are getting 1998 tokens for 1 Ethereum and 0.999 Ethereum for 2 tokens. These amounts are very close to the ones produced by the previous pricing function, wherever they are slightly smaller. Why is that? The constant product formula we base our price calculation on this, in fact, is a hyperbola. So that's the curve. So that's why I'm trying to put the formula here to see the formula as curve. But it's clear that I don't remember how to put the lines here. Hypersphere. Really? That's the way to spell? Cool. Cool. We can ask for joking. Oh. How to put that hyperbola? Now I understand hypersphere. A hyperball. hyperbole in the decimals. No way. No, no, no. No, no, no. No, 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 no. Okay, let's see. Now, that cannot be trusted. I want to see the curve. It's all fun and games until the equation generate an image naked vampet. They're gonna be terrifying. Now he's I don't know how to ask him to do that. Let me copy this. Let's see. Oh, it's X. Oh, it's X. Okay, they at least fix my thing. Where I can find the equation. I might be able to generate the hyperbole. The equation, what it is? This. The website is. I think a more easy way to go. It's Unisu. Oh wait, I can send the link, right? I'm crazy. I think you can open link there in Twitch. Otherwise, you can go YouTube too. Yeah, maybe you can generate the curve. So let me continue here the investigation. So the constant product formula, we base our price on is in fact a hyperbola. Hyperbola never crosses x or I. I think it's I, right? Epsilon in English. Thus neither of the reserves is ever zero. This makes reserve infinite. Okay, this is a new formula, right? Oh, wait. No, that's not the new formula. That's the constant formula. Indeed. What the points generated here? It's not the multiplication, right? Like 4 multiplied by 4? That's giving another point here. The point is like 2 and 2. That's another interesting implication. The price function calls price slippage. The bigger the amount the token is traded in relative to reserves, the higher the price would be. Yeah, that's the way you're gonna clean out the pool in the exchange, by the way. This is what we saw in the tests. We got slightly less than we expected. This might be seen as a drawback of the construct product market makers, since every trade has a slippage, whatever, this is the same mechanics that protects pools from being drained. This also aligns with the law of supply and demand. The higher of the demand relative to the supply, the higher the price. So the higher the demand, the bigger output amount you want to get relative to the supply, the reserves. The higher of the price, the less you get. In other words, if you want to take a lot of tokens against a small reserve. Wait, it's small reserve or is it higher? Yeah, it's small reserve. You're gonna have a higher price. So that's aligned with supply and demand. So because they has less reserves for the token you're taking, the price is gonna be higher. If that's a lot token there, so here for example, if we have a lot of tokens here, so they're gonna be cheap. So what you want to do to take money there, it's putting a lot of tokens here to make the price drops. That's why I took almost all Ethereum here. Here in the code, I think we put everything we have, and you can see where it is. It's not showing consoles. Okay, so let's, oh my goodness, it's a LSV. Sorry, I cannot make it work. Yeah, it's missing something in the formula. It's strange they say that's a hyperbola when I don't remember how to put the line. That is what? That's X. That should be pricing changing, right? Damn, big ass X. Yes, exactly. 256 bits. It's the base numbers on the Solidity language. So the Solidity language, it's a high level. U, the assembly language, all to produce bytecodes to run the EVM. So SIMD goes brrr. Yeah, there you go. I don't remember how much bytes are the limits for SIMD. Bits. SIMD is the same as, wait, now I'm a little confused. Oh, I thought it was something different. SIMD. No, yes. Wait. Oh, they say they can use 256. No, I'm confusing SIMD with something else about chips. The small chips, you know, the small chips. I think AVX can work with it. Okay, AVX2. That's our old technology, right? We still use this? And the current state of art. Oh, Ziggy. Yeah, that's not my ground. I thought the SIMD was you're talking about was the chips, small chips. Yep. A lose. AB. All right. Gonna trust him. AVX. Max clock speed. 2070 around that. Almond ships, yeah. Almond ships. Oh, they have a 512 bits. Or just name. Okay. I think it's the same, right? Single precision float number takes up the memory. You're right, 32 bytes. So with 8 float numbers each. 32. Let's see. Wait, 32 bits is not 1. No, it's 4 bytes. 4 bytes. Yeah, so we have something to hold more. Hold. Add into arrays. Cool. Nice. Talk directly with the processor. All right. So now we kind of understand his. So let's see what's expected. So they improved the test. Ridiculous. As you can see, when you try to drain the pool, we are getting only half of we expected. I'm not seeing nothing because I cannot see the error, right? Why are they skipping 2 and they won't have float point operation, but like in OP? The 2 came to fill the gap. It's just a big something. So yeah, I don't know why. Maybe the post it's old. I remember I had some processor with the 2, but it's after Pentium 3. I don't think it was 2027. Pentium 3 and AVX2. I'm crazy. Maybe I'm crazy. Yeah, I'm crazy. Oh, SSE. Oh, yes. Okay. 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 Oh, yes. Yeah, I'm MMX. Yeah, I had with the MMX. I was confusing. It's SSE2. Yes. Paul has a good memory. A good old memory. And that was implemented. Oh, process Intel Haswell. I see. So the MMX 64 bytes and SSE 128 bytes. 28. Cool stuff. Mind blowing 64 bits manipulation. It's from 2023. Damn, time flies. Yes, time flies. It's Still kind of new, but old, right? 13. Maybe. Yeah, let's see. Um, 2008 first proposal. 2011 MD, and here proposed 2013, but launch, yeah, 20, yeah, we can say and now what's the current stuff? Still using that crap? Free Pascal. Yeah, I used Hard Studio. I don't remember this stuff. I was too young. EIMM. That's the new stuff. EIMM. Oh, Full Metal Alchemist tree. You see here? IPC from 2020 do not have spot on. Yeah. Full Metal Alchemist tree here. Okay, we sidetrack again. That is so very cool, right? Okay, here. Where I'm seeing. Wait. Okay, MD is in 6. F. What the fuck is this? Oh, what's okay. What's compatible? Okay. Okay, even these days we have some that's not. Yeah, Full Metal. I cannot do big operations on the one cycle. Yeah, you cannot. You can see now I have Pokemon here. Intel Sapphire Rapids. Sapphire Pokemon. Nice. Cool. A final thing to note here is our initial reserve ratio based pricing function was not wrong. Okay. In fact, it's correct when the amount of tokens we are trading is very small compared to the reserves. But to make an AMMM, you need something more sophisticated. Swapping functions. Okay, now we are ready to implement swapping. So Ethereum to token swap, minimum tokens to receive. Swapping ethers for tokens means sending some amount of ether storing. Okay, so I think that's enough information to crack the stuff, right? So the thing is, we put a lot of tokens there and took Ethereum, right? Now, can we make the price drops so much where we can drain all the exchange? Let's read again what we need to do. So that's a lending pool where users can borrow. Oh, we can borrow. Oh, yes, we can borrow. So that's the thing. You can borrow. So what we need to do, we need to borrow a lot DVTs. Wait, we cannot do borrow. Wait. To do so, we first need to deposit twice the borrow amount in Ethereum as collateral. So we have some collateral. We have 25. We have 25 plus where we got an exchange. That should be 9.9 Ethereum, right? So we have 25. Let's go. Yeah, let's go 9. I need to deposit twice, so I can just take this. If that's 1 by 1, 1 per 1, but that's not 1 per 1 anymore, right? Right? Because now the price for this is this number that I don't know how much it is, but we have chisel here. Chisel, it's like Python REPL for solidity, and that gives nothing for me because I want to divide by, yeah, I cannot do that. I cannot have here. I need to like multiply by, I don't know. Let's put how much zeros there. No, I need a lot of 8s. Let's go easy. Let's go like 8. Then I divide by 18. Still is not enough. So let's go 10. Wait. Something wrong here. There. Sum up. Okay, so that's 10, right? So that should be what? Oh, that's done. Okay, let me count 3. Let me count. Let's go manually counting stuff. Cyberchef. Here we have 14. It means dot 0. It's 1 and 3. Right? Am I crazy? We can do. Can I do that in here? Like if I divide by these. I think that's correct. Okay, that's the price for each token? Really? Okay, so it's easy, right? You just need to give the double. Okay, maybe we're gonna have the problem where we made the price so cheap, so cheap that it's gonna break stuff. Uniswap V1. I don't know why it's not out completing. Exchange. It's borrow. They have borrow. No, I think it's take something. No. It's not here. It's here. Borrow. It's in Puppet pool. And a Puppet variable pool called lending pool. Wait. Why is it not green? Here's green. So lending pool. Come on. What's my out completed? Lending. Terrible. Borrow. Okay, at least that works. That's not working. Amount in recipient. Okay, I'm gonna give myself, right? The end question is pass the challenge saving all the tokens from lending pool, then deposit them into the designated recovery account. You start with it, and so I need to go to recovery account. I could put the recovery account here, right? So the amount they need to calculate the deposit required. I need to have enough send on that variable that's payable. And I can now re-entrance. And here, see the value is greater. You're gonna send me the exchange back, the change, right? The change back. And here, they're gonna, why? Why they have deposits? They don't use deposits for nothing. Maybe they're gonna use in the Puppet 2. Okay, so the amount we want to borrow, it's everything they have. This is represented as this. And we can go to recovery address. I don't need to do that, but I'm gonna do. Twitch hate me. Sensor goes hard. You try send links, right? Okay, I think I need to make you become the boss in the chat. Let me open here. This browser. It's opening another monitor. Not enough collateral. Oh, of course, you need to send value here with, I think we can send everything we have. Why not? It's not this, it's player. Okay, so I need to go to Twitch. Also, that's the problem. I cannot, can I open Twitch like that? Twitch. Oh, I need to sleep soon. I have 2 meetings tomorrow. Okay, it's trying to load here the chat. No, then I can put you as like an administrator or something. Then, yeah, midnight already. Time to go. Just let me put you as admin first. Just you can send links. Then you are free to go. Here. Wait. No. Yeah, definitely I don't remember how to do that. Oh, okay, moderator. No, I found. Yes, moderator now. Oh, it's not a link? Oh, it was bad words? Oh, so was that a good sensor then? Okay, now you are moderator. Yeah, so did the borrow, and let's see if that's correct. All right. I think. Okay, Lindy Pool has tokens yet? It's not possible, right? Something failed before. Layer balance. What's the error? Yeah, borrow. Yeah, like we do the calculation, 34. We send to recovery. I'm a mod. Yes. Unlimited power. My dictatorship start now. Yes. Probably you're gonna rule over all. Not a lot people to rule now, but you know, you need to start somewhere, right? Huh. Okay, I received some exchange here. Okay, they did the transfer. Wait. That's our tokens. Wait a second. Wait, we took the token. So the player should have 1 ounces. And I don't know, that's 0. Don't make any sense. I need to deploy something, right? It's have some problem here. And yeah, that's the problem. They have some bugs here. I want to see how to fix that, because I would want to why get nonsense here don't get increase. It should. I know if I deploy contract, that's gonna be increase. But why others functions? I should be using my vibe typer. It's not mine, but I don't know if vibe typer works when I'm using the same microphone. They should be working. Where is the mic? Yeah, I think it works. We can test. Okay, so they said, short explanation. No set returns the AOA transaction count, the number of external transactions the address has sent. Only externally sent transactions increment the nonce. Internal calls, message that happens inside the transaction do not increment the sender node. Yeah, makes sense. True. Why you sometimes observe no increase? Nonce increase only with the AOA sends out on chain. Signed transacted nodes processes. You, the player, submit the transaction that call a contract. Wait, I did that. You deploy a contract from. Wait a second. I call a contract as a player. This. Okay, I'm gonna just hack. The hell is vibe typer? So vibe typer is something I can type as vibing. You know, as vibe coding. You know the concept of vibe coding. I want to deploy a contract here. So let's use the vibe typer. Deploy a contract, any contract, don't matter, just to make sure we have that increased. You see, my face on the top. You can all see the magic happening here. So more easy, right? Why you do that? To type for me using my voice, my beautiful voice. It's more easy sometimes. And it's supposed to be used as vibe coding, like with AI too. Why you vibe coding? Why you use vibe coding? Man, I built so much with vibe coding. Like so much in the last year. Like so much. Why I need coding? Like why coding? Tmux, TL for list Tmux. That's where my Claude's army are. And I can go like go to here some project I just released using Go for desktop, Go for server, and Flutter for Android and iOS. Building for a lot of architectures too. Like, why am I gonna code all that stuff manually if I can vibe code it, right? Let me move my. Oops. You don't like vibe coding? You're the old school guy that like crack around, move some bits with your teeth. I like do something coding too, but more for like these or for algorithms where I need to improve something in myself. Okay, here they suggest some way to increase. Yeah, that's bad. Just very bad. They create a new contract just to increase? No, no, they. Yeah, that's why I don't like use Mini. Mini is so dumb. Normally, I don't use that AI. I use Cloud Code only to create code. So let's just deploy new damn. I think it's valuable. Yeah. Come on. What's my. Yes. I know what the AI does in the fundamental level. It can only do what the average developer had done. Uh, the average developer? No, I don't think so. Since it's kind of copies. And for me, the average developer is incompetent. So I don't trust this too much. Yeah, okay, the average it's incompetent. Yeah, it's true. But the AI do more than the average does. Much more. Um, yeah, they are improving a lot, kind of a lot. And if you are a good developer, like if you are ever developer using AI, you're gonna produce average systems and codes, or even a little more up. But if you're a great developer using AI, then that go without limit. In model, it's based on open more than ever the public repos or bad developers. So, yes and no, right? Like you consider like Unreal Engine made by bad developers or Linux kernels or I don't know, take any C++. They are not they are trained in good code, not all available code out there, especially cloud code, cloud models. The last model was like they improved with new or good patterns to code. But yeah, give it a try. But use cloud codes, not any other like these. Even if you put cloud here, it's not the same as using cloud code because the cloud code has some good patterns to create and manipulate codes. Anyway, let's see what's happening here because we need to sleep, right? We are human, we are not machines, and they create the class that we don't need it. Let's go to trash. So I'm using Mini here. So Mini really it's average developers. Mini and Haiku. So they are very dumb. to create code. You need to be very, very specific when to, or you need to be creative. Yeah, like a kind of juniors. So it's not average, right? Oh, it is. The report that contains such codes are often slightly modified copies of the good code. So this would be about only capable of doing something in that range. It's not true. It's not true. But yeah, you can think it is. I don't mind. Oh, we passed. Wait, why the test pass and we still have some problem? Wait, now it's failing. What? Oh, wait. Oh, because puppet, we have 3 puppets. Oh boy. We need type puppet C. That's why it was so noisy there. Yes. So the curvy fail, but we don't care. These we care. We passed. Nice. We hacked. We hacked the thing. Okay, that's good enough for today, right? So to recap, what happened was the formula here that say that it's constant, the real formula is not this, it's this. And this formula, even this formula too, gonna do that. I'm gonna keep constant, right? In each exchange, they're gonna keep in change the prices. So because we took all Ethereum from, we need to put some tokens here and make the DVT price tokens drops for 0.0009. So with that price, we can borrow all the DVT available. They have 100,000 DVT available just with the requirement of the double of this. So that should be this, right? So I just need to have, wait a second, 180. No. I'm that's the price. So wait a second, 90. I put 34. Maybe I'm missing zeros here. Maybe I'm missing zeros. 1, 2, 3. Yeah, I think that's, wait, it's still 36. Okay, I'm not happy until I fully understand the mathematician behind this. I'm not happy. Sorry, I'm not happy. Okay, we put 1,000. Then the price drops by a lot. So the easy way to understand this is we go here. That's a little hack. It's not a hack, right? Just being a coder. We can put some console logs here and just see how much deposit is required. Solidity has debugger, but I never use debugger for Solidity. That's something for another day. So here I can go like this. Why need type C? I can do it for me. And yes. Yes, I can go console log message value less. Yes. And here don't matter. And here the amount. What's the amount? The amount is how much you ask. So let's go here. It's not, no, it's not this. This is good. I want amounts. So input amounts. Amounts. That's missing these. Okay, so let's run. They have a way to run exactly the name we want. Never mind. Okay, so the amount we ask is this. The deposit required is this. Let's copy and divide by. Yeah, exactly. So let's see. So I was really missing 1 0. These multiply by, how much is this? Plus 9. So 9. Oh, yeah. So yeah, I don't know how I did that. Yeah, those multiply by 2. Only this is necessary. So if I send like 20, that should be enough. Yeah. Very good. Now you are satisfied. And the next one for another day should be the puppet 2. So we are in the 8. That should be V2. Numbers do be numbering. I need to translate this. Normally I have my private key. Oh no. No, that's not my private key. I hope. I have my translator in another. Wait, why did this? I'm gonna check later. Okay, I was. Oh, that was happening. Here, Puppet V2. So developers of the previous post seem to have learned the lesson and released a new version. Now they are using Uniswap V2 exchange as a price oracle, along with the recommended utility libraries. Should not that be enough? No, it's not. You start with 20 Ethereum and 10,000 DVT tokens in balance. The pool has a million DVT tokens and balancing the risk. Save all the funds. We're gonna not do that right now, but I want to see. Why not? So the difference here is they're using V2 now. So all that knowledge we have from the V1, we don't kind of need it anymore. So let's go to book V3, because inside the book they had links for V2, first part series. So the V2, they're gonna say how that works. They have a contract called pair. And also is the pool. They have the token that the pair extend called LP tokens, the factory and the pair. So pooling liquidity. So they have the reserves. They have got a cool mathematician libraries. They have the mints with balances, supplies, etc. Here the beautiful formulas. Beautiful formula. Now, because they're gonna, yeah, that's the same, to be honest. Keep the same. Now keep the same. Minimum liquidity. Yeah, that's a good stuff to learn. But I'm trying to remember the difference here. Wait, what's the difference? We lost token. Try figure out how who even to get the half the pair test use. Okay, the problem gonna be here. I don't remember what he's talking about here. Oh, I think it's about removing liquidity, right? Oh, I think here gonna be about impermanent loss. Maybe. Pool pair factory, the two tokens. We have borrowed them. Now here, no. What the fuck is that borrow that don't require I pay you back in the same block? Ah, because of a collateral. Okay, collateral. Then here using the cat reserve. Wait, but they don't. That is not the same formula. Let's see the quotes. That's the same formula. Right? It's the same formula. So the attack should be the same. Okay, I think the V3. Ah, really? Okay, so a little disappointed. Yeah, a little disappointed if that's the same. I hope they did not the same. So in the other should be free rider, backdoor, climber. Yeah, we are in the halfway, right? So let's go sleep. I need to study some algorithms tomorrow. I'm studying dynamic programming. I'm gonna put in the chat John Hackman. Yeah, kind of. John Hackman. Put it a link of what I'm studying. I'm gonna sleep, but I'm gonna put that video to watch before sleep because I need to understand more better about dynamic programming. This code, a little code. So thank you, Paul, to be here, talk with me. Muito obrigado por estar por aí ensinando a gente algumas coisas sobre CPUs, outras coisas, pelas piadas também, muito boa. Oh, não, achei que você tinha mandado outra coisa. And thank you, people on YouTube too, and the Twitch, and see you the next time. Probably tomorrow. Not sure. But yeah, let me close these. Why is it's red? Close these. I close these. Oh, that we're gonna use swap Oracle. Nice.